All right, you guys. Well, this video doesn't really have any new information per se, so much as just problem solving on how to combine past information. So the idea here is, what if we've got these irregular shapes, or we call them composite figures. Composite means they're just composed of more than one thing together. Like often your desks are composite woods, because instead of a solid piece of wood they cut from a tree, they just kind of grinded up some tree garbage, like leaves and twigs, and glued it all together and squeezed it. Or composite materials is when you throw like three materials together. So anyways, how we would solve number 3 is either we would add together the area of two things. So here an area of a rectangle and the area of an isosceles triangle. That's how I'm going to do it. Or we could have seen it as the area of a rectangle and then taken away, subtracted the area of two triangles. Either way is totally valid, and we're going to do it differently on different problems. So in this case, I'm going to add, and in different scenarios, I'll say, you know what, in this case, it looks like it's easier to subtract, but both are valid. All right, so in this one, we have the area of a rectangle that is 3.6 by 9.2, and then we are going to combine that with the area of an isosceles triangle that is 9.2 on its base, and then we subtract the height of 8 here minus the portion that we had was 3.6, so the leftover there is a height of 4.4. So the area here is the base times height of this left one plus the 1/2 base times height of the triangle. So the overall area is 3.6 times 9.2 for the rectangle, plus the area of the triangle, which is 1/2, the base is 9.2, times the height is 4.4. All right, and I'm just going to stop there. I won't do the arithmetic. So here we go. Let's go to the next one. So they give us this big juicy dot here, and they say from this dot's center half circle area over is 32. So we have a rectangle. So really the total area here, and this is the way I write it, I go area total equals area rectangle plus area of half circle. And so that's how I'm going to split it up in this problem. So here we have the base times height plus, now the half circle would be 1/2 of a pi r squared. And then we just need to put in values here. Well, we know the rectangle, right, was 16 by 13. So we go, okay, well that's not 13, 16 by 32. And then we're going to add, so 1/2 of, and then pi, what's the radius here? Well, we know all the way across is 16. That's the diameter. So that means the radius is 8. So we go 1/2 of pi, 8 squared. Now, gosh darn, let's start plugging things in. We can't just avoid arithmetic on every problem. Okay. On the left there, we get 16 times 32, which is 512, plus 1/2 of, and this is going to be 64 pi. So 1/2 of 64 pi is just 32 pi. So the area here is 512 plus 32 pi. That would be the exact area, or you could approximate it by putting it into calculator and getting an approximation. So let's do that first problem though. 3.6 times 9.2 plus 1/2 of 9.2 times 4.4. And we get that is exactly, not approximately, but exactly equal to 53.36. Okay, let's go do a couple more. So here, I'm going to do a cool little thing here. Look at this. I could chop it here, and we have these are the same as these down here, and they both have a 5 on the bottom. So that means this side's the same as this side. So by SSS, those are congruent. So I could just slide that into this spot, and now all we have is this is equivalent to the area of a rectangle that's 5 by 10. So for number 8, we just have base times height, 5 times 10, the area is 50. So that's how I'm saying we can sometimes add, we can sometimes subtract, because really what we're saying here is the area is equal to a rectangle minus this isosceles triangle plus this isosceles triangle sticking out on the other side, right? Because here's the middle portion. We had a rectangle and we deleted a region, so we subtracted an area, and then we added that exact same region over here So that minus plus cancels out, and we just get the area of a rectangle. Very cool. All right, so for 9, it's very clearly subtraction, right? We would close this. Actually, let's use a different color to separate the problems. We close this and put a center there and go, well, if all the way across was 8, that means the radius here was 4. And so the total area is going to be the area of this rectangle minus the area of half of a circle. So that's going to be base times height for a rectangle minus the 1/2 of pi r squared. So this is going to be 8 times 12 minus 1/2 pi, and the radius is 4. So we get that's 80/96 minus 1/2 of 16 pi. And so that's 96 minus 8 pi. Again, you could absolutely jam that into a calculator and get an approximate answer. All right, this one over here, very clearly we're going to add, right? We're going to add the area of a rectangle here plus the area of the triangle. And so this is, so the area total equals the area of this rectangle plus the area of this triangle. And so that's going to be what? Base times height plus 1/2 base times height. And then we're going to have, what's this? This is a total of, we went 15 and 10, so there's a total of 25. So we have a 12 times 25 plus, and then we have 1/2. Now the base and the height of the triangle we got to figure out here. So what we know is that this is a right angle. Again, we're making these assumptions that all these things in this chapter look rectangular are, which is something we did not do in the first 8 to 10 chapters of the book. But now that it would just take way too much time in 2D and 3D figures to show right angles at every single point, or to label these shapes, because this isn't a known named shape. And if they said it is a rectangle with a right triangle glued on, it kind of gives you the answer on how to solve it. So yeah, we're making some kind of assumptions here. But anyways, just zooming in here, we have the base of this triangle is 10, and then we need to find this height of the triangle over here. Well, we know this is 12, so this side opposite is 12, and if the total is 20, that means this piece is 8. And so we have a 10 times 8 there for the base and height of the triangle. So 12 times 25, that's 3/4, so that's 300 plus 1/2 of 80. And so we get, that's 300 plus 40, so that's the area is 340. Okay, this is good, you guys. This is just a quick little bunch of problems. Whoa, this is crazy town. All right, so for the one on the left is pretty straightforward, right? We're just going to use a rectangle and a triangle, so let's do that. So we have area total equals the area of the rectangle plus the area of the triangle. We have base times height plus 1/2 base times height. The base and height over here is 62 and 54. The 1/2 and the base and height over here is, the base is the whole 62 of the triangle, and the height is the 27. So 62 times 27. Oh, that's interesting, because 27 is already half of this, so we're really getting like 5/4 of that or something when we do it. Anyways, 62 times 54 plus 0.5 times 62 times 27 is, and we get area is 4,185. And that's exactly. Okay, so then let's switch colors and do the middle problem here. So I see this as 2 of the exact same trapezoid on top and bottom. So we have these 2 trapezoids. So I remember the area, so the area total equals 2 times the area of a trapezoid. And I know the area of the trapezoid is 1/2 base 1 plus base 2 times height. Well, the 2 times 1/2 just cancels, and so we get it's base 1 plus base 2 times height. And so the base 1 and the base 2, we add the 8 and the 23, and that's times the height of 10. So we get that's 31 times 10, or that the area is 310. This is cool. I like this. So this other one over here, we could see this as the area total is equal to the area of an entire rectangle minus a half circle on the left and minus a half circle on the right. Or another way of saying that same thing, right, is the area of a whole rectangle minus, if you take away two of the same half circles, well, two half circles makes one whole circle. So we just take away the area of an entire circle. So here that's going to be base times height minus pi r squared. So in other words, 22 times the height is 14 minus pi, and then we need the radius, so the whole diameter is 14, so that means we have a radius of 7, so pi 7 squared. So let's figure that out really quick. 22 times 14, so that's area is 308 minus 49 pi. Okay. What about, okay, we need these windows replaced with the window panes, find the perimeter of the window, and then find the area of the window. Great. Well, we just chop this window into a circle, or a half circle, I should say, semicircle, and a rectangle. So it says find the area and the perimeter. So the area is, or the area total, that's the way how I like to write it. So the area of a rectangle plus the area of this half circle. So we have base times height plus 1/2 pi r squared. So that's 36 times 48 plus 1/2 of pi. And then we need the radius. So the radius here is half of the 36. So we have 18 and 18. So pi times 18 squared. So just figuring that out, 36 times 48, that's 1728 plus, and then 18 times 18, and divided by 2, that is 162 pi. All right, so that's the area. Now we need the perimeter. So the perimeter here is going to be, you got three sides, so the perimeter would be this 48 plus 36 plus 48. So we got 48 plus 36 plus 48. And then we plus the half of the circumference, right? Because we go halfway around a circle. So there was a 48 plus the 36 plus the 48, so three sides of the rectangle, and then plus the half of the circumference. So adding those together, we get this is 132 plus, and then half the circumference is half of 2 pi r. Well, the half and the 2 cancel out, so we just get pi times radius. And we know the radius is 18, so the perimeter is 132 plus 18 pi. There we go. Okay, let's do some more. Okay, so these are our last problems here. So this is actually a review of the last section where we have some regular shapes. Not all of them, but find the area of the shaded region. So here we have the area total, equals the area of the square, and then we minus the area of the circle. So this is just a side squared minus pi r squared. And so what's the side of the square? Well, the radius touches both the top and the bottom. So the diameter of this would be 14. So the area of the square is 14 squared minus pi, and the radius is 7 squared. So 14 squared, I think, is 196. Just double checking, it is. So the area here is 196 minus 49 pi. All right, switching colors here. The second one. Now, remember, if we have an inscribed angle of a semicircle here, and we know that's a diameter because of that big juicy dot. So this is a 180-degree arc. So inscribed angle of that means that must be 90 degrees. And so then this is a 45, 45, 90 triangle. So this is also 12. And so what we have here is the area total equals the area of the circle minus the area of the triangle. And so this is pi r squared minus 1/2 base times height. So this is pi, and we have to figure out the radius squared. Okay, so I'll leave that blank for now. Well, we'll need a little more room because it'll have a square root 2 in the answer. So squared minus 1/2, and the base of the triangle and the height are the two legs because they're perpendicular. So we go, oh, so that's 1/2, 12 times 12. Great. Okay, so now we just got to figure out the leg there. So let's just say, well, this is similar to every 45, 45, 90 triangle that has a 1, 1, root 2. And so all we did was we multiplied by 12. So this whole thing is 12 root 2. And that's the whole diameter. So half of that is 6 root 2. So we just put a 6 root 2 right there. That's what we figured out. Okay, back to this color. If we square that, we get pi. And then this is 36 times 2. Right? 6 squared is 36. And square root 2 squared is 2. Minus, and this is 1/2 of 144. Okay, so this is 72 pi minus 72. That's cool. All right, so that's the area of that one. All right, let's switch colors one more time. We'll go purple this time. We'll zoom in. All right, so this one, whoa, we got a regular hexagon. This is crazy. Well, remember regular hexagon, and the reason I know it's regular, it says assume that all polygons are regular unless otherwise stated. So this is a regular hexagon. So we know the area total is the area of the circle minus the area of the hexagon. Okay, well this is just pi r squared, and we're given the 16. So this is just pi 16 squared. That's easy. So what we really have to do is find the area of this hexagon. Okay, that's what we're up against. Now you've got two ways to do it, right? The given formula for finding the area of a regular hexagon, or I mean the area of a regular polygon, that's rep. Regular polygon is equal to 1/2 the apothem times perimeter. So the apothem would be this height straight at the side. So we have the radius is 16, but we need the apothem there. And then the perimeter would be just, obviously, you add up all the sides. So that's one way we could do it. Or the other way you do it is you go the area of any polygon is sum of triangles. And so we could just cut this into triangles. There'd be 6 triangles. And if we find the area of the triangles, we just go 6 times. And because it's regular, they're all the same. So we go 6 times the area of just one of those triangles. Okay, so which way should we do it? Let's use the formula this time. I, in general, probably do the triangle method more often. But let's do the area of the regular polygon formula this time. All right, I'll switch colors for this. Let's go to orange. Okay, well, we know there's 360 degrees in a circle, so we divide it by 6, and we get each of these is 60 degrees. And so if each of these is 60 degrees, and this is an isosceles triangle with 16, that means each of these is 60. And so in case you didn't remember, all of these are made of equilateral triangles. That's only true in a regular hexagon. It's a cool little thing that happens. That means all these are 16, these are 16. Okay, so what we really have here is we have the perimeter over here is 6 times 16. Okay, that's the perimeter. Now we just need to find the apothem, and then we have the 1/2. So the apothem, let's do it really quick. I don't know, up here, why not? So the apothem then is 16, 16. We cut it in half, right? It's a symmetrical, not only is it isosceles, it's equilateral. So we cut the bottom into 8 and 8. And we have a 60, 30, 90 right triangle. Or you just Pythagorean theorem because you have 2 sides of the triangle. But I know that this is similar to 60, 30, 1, root 3, and 2. So we multiplied by 8. So this height is 8 root 3. So 8 root 3. That's the apothem there. I used 30, 60, 90 triangles, but you could have just used Pythagorean theorem there, or you could even use trig. All right, so anyways, let's do this. So, whoa, 8 times 6 times 16, all divided by 2. So that's 384 root 3. That's the area of the regular polygon. So down here we go minus 384. Whoa, I said 88. 84 root 3. That was what we got there. And then going back to purple, we get this is 256 pi. So that's the area of that shape. It really came down to find the area of a regular polygon, which is kind of hard. Okay, there we go. That was it. Hope you enjoyed that short little video just demoing doing some of those problems.